Everyone, welcome to my channel. Today I have picked really interesting topic and I'm going to talk about two-pointer and binary search techniques. Almost 25 to 30% of the array problems and 15% of top interview problems can be solved using these two techniques. So if you don't know yet, if you haven't learned it, this is a very important video for you guys. If you don't know yet, linear search and binary search are two important searching techniques, okay? And let's take a real life example. You are given a set of rooms and suppose you have to find a person, suppose Elon Musk, who is in room number 15 right now. So here the conditions you are given that the rooms are in a sorted fashion, means that the room numbers are in an increasing fashion, and it is not necessarily that they are going to be contiguous. Suppose you are given, you are having 4 here, that does not necessarily mean that the next room number is going to be 5. It is going to be anything which is greater than 4 but not necessarily 5. So the second scenario is this. Now what you are going to do, the basic approach you are going to use, you know that if we start from 2 and you have to reach up till room number 15, you would check for the first room, which is room number 2, second room is room number 3, now fourth room is room number 9. You will do this and you will check and you will reach up till 15th room number. So you have to check all the possible scenarios like this. Suppose this is almost near to the worst case because you have to reach up till or near to the end. So this is going to give you a time complexity of big O of n. Now the organizer of game is definitely not going to be happy with you because you are taking a lot of time, which is big O of n. He is going to say that you want a time efficient approach. You have to work on time, okay? And you cannot take this much because of end time, because you have to apply all your brain and you have to think of something better and smart approach. You have participated in this game, but your friend is also waiting outside, so now you are thinking like a detective, and you both are going to use some smart approach. You are going to work in an efficient manner. What you will say that, okay, me and my friend, we both are going to compute the total number of rooms and we will divide it by 2. Suppose it is nearly equal to 7. So we will just ask receptionist where the 7th room fall, not 7 room number, but 7th position of the room. So the receptionist is going to tell you that, okay, room number 7th room, which is 11, falls at midpoint. Like, you obviously have computed the midpoint and you have computed at mid position. Ignoring all the scenarios, ignoring all the cases, you just reach to the midpoint. You have reached at mid position and you have found out that the current room number at 7th position is 11, which is less than the room number you are trying to find, which is 15. You will say that, okay, now I know that I don't have to go backward where the element have the lesser value, but I have to go towards where the room number has higher value. So this is the smart approach you have used, and using this approach you have already reduced your problem data to the half. Now you have to you and your friend again, you are going to use the same approach in the same fashion. You are going to compute a middle point. You will ask the receptionist. In this case, the middle point is going to be here. And then when you reach that middle point, you already found out that, okay, okay, you have reached and you have found the person. You have found the 15th room number. This way, your time complexity also got reduced. Linear search is linear. I have already added short notes. You can go through it and you can note it down. You can pause the video and you can note down the important pointers that I have added. So this is how binary search works, which I have already discussed, that it takes two pointer. One pointer is at the starting, one pointer is at the ending. If you have to find the target, then it is going to compute the middle position. It will check, okay, you have to find 7, but the middle position is lesser. So you are going to discard the left half and you will just move towards right half. And in that case, here at right half, you are going to find the target like this. So I'm going to discuss few possible scenarios where you can find out that this problem can be solved using binary search. The first problem, which is a very famous problem, is already a binary search, okay? Again, and second one, you can use that, okay, the hint could be the data is sorted. When the data is sorted, you can apply binary search. Third is when you are asked to find maximum or minimum, the problem would be like, the problem would say that minimum, find something minimum such that, or maximum x such that. Okay, so the few common LeetCode problems are binary search problems, and then binary search problems, which is a classic problem. Then you have to search in sorted and rotated array. Whenever search comes na, you should have like binary search is going to come, you can say that, not definitely but most of the time. And then find minimum in sorted and rotated array, like this, which what I have told, minimum in sorted and rotated array. And then you this one is really important, find peak element, or find insert position as well, insert position, something like this. So these problems, and I have written these problems, you can try out these problems on your own, and one by one I am going to discuss these problems in my own channel as well, you can refer them. So this is how you are going to solve binary search. Here the interesting thing is that while explaining binary search, I have already given you hint about two pointers. So what these two pointers are, you can take a pause and guess what these two pointers could be. The two pointers, they are obviously you two initially, the two of you friend, like you and your friend, what you were doing is definitely is exactly what you and your friend were doing initially, is exactly what two pointer does. Two pointer here, it can, in this case, in your scenario, the you and your friend were at both ends, computing the middle point and then moving inward. So this is the first movement of pointer, that the two positions you were moving inward. And in the binary search, you see both pointers, like left and right pointer, they start from the very end of the array and move towards each other, and they will move until they cross the path. They don't, until they reach towards each other, they don't cross it, they never cross the path. They will stop the moment they have reached at, like, towards each other. This is how two pointer also work, two pointer technique, that you are moving left and right pointer towards opposite ends. Second pointer movement, obviously I am going to discuss two pointer in detail in the next video. So second pointer movement is that you are given an array problem, and then you are using two pointers, but there is some scenario that you have to compare elements, or you have to remove duplicates, or you have to, like, remove some part of the array, you have to work on windows. In these scenarios you can move two pointers, but they are going to move in the same direction. In both of these cases there is just going to be one array. Okay, but so the third scenario is you are given two array or two linked list, and then you are going to be moving in a parallel fashion. Then you are going to use two pointers. Thank you for watching my videos. Keep learning, keep coding. We will continue two pointer in next.